Hello everybody, I think we're live. If we are live, give me a thumbs up, let me know. Let me know where you're from. Good morning, good evening, GM, good afternoon, good time of day to you. I'm not seeing things show up on the YouTube though. There we go. We are live, fantastic. So there's a few of you here. We're gonna look into Foundry. I'm gonna try something new today. I've pre-recorded a bit about Foundry, just to kind of speed things up. But I will be hanging out in the chat and then I'll pop back on here after the video to answer any questions that you all have. So hopefully it's kind of the best of both worlds. You don't have to watch me stumble through typing and do anything silly. But if you have questions, I will be here. I'll be in the chat. I'll pop back on after, like I said. And yeah, hello. Wow, we got people from Nigeria, Pakistan, fantastic. All over Australia. Whew. It's probably like pretty late in Australia, I think, right now. Whew. Anyway, thanks for showing up. So I'm gonna start this video, and then, like I said, questions in the chat, and I'll be back.
Hey, I'm Richard, one of the developer advocates here at Chainlink Labs, and today we're going to be taking a look at Foundry. Now, what is Foundry? It's essentially a smart contract development toolchain. It lets you write your smart contracts, compile your smart contracts, test your smart contracts, and even deploy your smart contracts, all using Solidity. It's pretty awesome. If you've used something like Hardhat in the past, it's similar, except for you don't have to do anything but write Solidity code. And I think that's kind of great. Now, it does come with some minor limitations, like you can't reach out with JavaScript, hit an API to get a result back when you're doing things like testing. But the fact that you can keep your brain all in the Solidity space, I think is a massive advantage. So how do we get started with Foundry? Well, if you head to book.getfoundry.sh, you'll see this website. It's Foundry's documentation, and it is a great resource and walks you through everything you need to get started. So let's look at this and see what all we need. First thing we'll do is we'll head to installation. We need to install Foundry. Now it asks you to curl a script and run it in Bash, and I always like to double check and see what exactly these scripts are doing. So if you look at this URL, you can see here what it does, right? And you can kind of look through this if you want to read through it more thoroughly and make sure there's nothing crazy and malicious going on. That's always a great idea when it comes to running someone else's code on your computer. But, you know, I've looked through this before. It looks pretty good to me. So we'll just copy this command and we'll head to VS Code. Now I'm going to be doing all of this in VS Code. You don't have to, you could use a terminal for these steps. You can use whatever editor you like. I've got a folder for Foundry already set up. I have VS Code open. You can see there's nothing in the folder. In the terminal, I'll go ahead and run this curl Foundry and pipe it into Bash. It says here, hey, you've got your preferred shell set up as ZSH. That's the default on macOS. And you need to add this to your Foundry. It says go ahead and run this command here to source that because we've added it to your path. So we'll source that. At this point, we should be able to run Foundry up, and that will go ahead and check and make sure and install everything that needs to be installed for Foundry. So we should be good to go there. So we've done that. It has here for Linux and macOS users to use this bash RC. I think that's maybe slightly out of date given what we just saw in the script. So we're good there. So at this point, we should have access to things like Forge, Cast, Anvil, and Chisel. We'll be talking about Forge a bit, not so much the other ones. Again, their documentation is fantastic if you want to look at those as well. So we've got this installed. We're ready for our first steps in Foundry now. So let's take a look. So just to double check that we have Forge installed, we do. It requires more options than that. So we've got Forge installed. So we can do Forge init. Now this will create a default project called Hello Foundry. I would like to just do it within my Foundry project here. So we say Forge init and dot. The dot means here where we currently are. And we're currently in the Foundry directory. You'll see over here now we have a ton of stuff that just showed up, right? So this is the basic Foundry project. Let's take a look. Let's tour through this really quick. We have a git ignore. Always important to ignore things, not commit them to Git, especially things like .env files. If you have private keys and stuff like that in there, you never want those going to GitHub. We also have Git modules. It's kind of like package management. It has some paths for where things will be. We have foundry.toml. This is the config for Foundry. We also have in here a source directory. This is where our contracts will go, you can see that it has a super basic contract here. And they've actually updated this since the last time I looked at Foundry, which is great because it used to be this contract was just a contract with nothing in it. Now it's a counter. That's great. So we've got our counter contract here. This basic one has a public number. It sets the number with a function. You can also increment the number. Sweet. We have a test folder over here. What do you think lives in the test folder? That's right, it's tests. So we can see here a basic Foundry test. How this is set up, again, it's all in Solidity. So we import the testing framework. We also import in that counter contract that we saw just a moment ago. Looks like this sets up a counter contract called counter. We do that in the setup. So counter is a new counter. And then we set the number to 0. So what does set number do? Let's take a look here, both of these side by side. So set number will set the number for our initial starting place with that number. Great, so that happens in setup. One thing to know about Foundry is this setup will run before the tests are executed. So how does this setup work? It runs before each of the tests, basically. When I say basically, what I mean is the actual block state of the setup gets run, and then there gets to be like a pin put in that block state. It'll run a test. Things will change on the block, and then it'll revert back to that block state. That saves a lot of time. So you don't have to like reset everything. You just basically rewind history at each one of your tests to make sure you're back at that initial starting point. I think that's super cool. It's one of those things that Foundry does that makes things just go super fast. We've got our first test here. It's test increment. What that'll do is it'll run this increment function, and then it will assert that the counter number is incremented by 1, right? Because it started as 0 and it should be 1 now. And then we have a test set number, and this will run counter set number and asserts equal to that value. So how do we run this? What do we do here, right? So like if we look at Forge and we look at the options that it has, we have options like Forge build. That's going to compile this contract. So we could run that. That would compile the contracts in our source directory. We have Forge test, which will run the tests. So let's try that first. So let's run Forge build. Let's make sure everything works. So it's compiling all our files and it ran successfully, right? What if we had something like a error in here? So function, and this is going to just return a return error, right? What happens here? This doesn't look like it's probably going to work. Forge build. Hey, look at that. We get our parser error. So this will let us know where the error is, what's going on. Cool. Let's go ahead and get rid of that. We'll save it. We'll run our build again, make sure everything's good. Awesome. How do we test? Forge test. So this will run our tests. And they've really done a great job with Foundry. This is definitely different than the last time I ran through the init. We've got here our first test increment. It passes. Cool. That means that we can increment this value by 1. We also have another test set number, and this is awesome. It's a fuzz test, like built in to the like starter Foundry project now is a fuzz test. What is a fuzz test? Fuzz testing is where you throw random values at the contract. What does that mean when I say random values? Well, if you notice here, it takes in this uint 256 of x. Nowhere in this file is x defined. Right? So what Foundry will do is it will go and then run 256 different random values. It'll just throw them in there and make sure that it works, right? Because we pass in, say, 123. And we set the number to 123, and we expect the counter to be 123. That's pretty cool. What else could we do? Let's write a new test real quick. Let's say function, test, set, and increment. And we'll make it a fuzz test. We'll say uint 256, y, public, and in here we want to say counter dot set number to y. If you notice that gray stuff down there below, that's going to be GitHub Copilot. And so then we'll increment once, and then we'll assert that our number is equal to y plus 1, right? So this is kind of a little bit more involved test. We make sure that if we set to a random number, our increment also works. We'll give this a save. We'll run Forge test one more time. Oh no, what happened? Something happened here. Arithmetic, overflow, underflow, counter example. I'm betting what happened is that the data that was passed in, yeah, so this number here is going to be at the top of what's available as a uint 256. So how do we fix this problem and ensure that the y that we're passing in is at least one less than the maximum? Well, we can first do something like this. We can set a uint max int for ourselves. So what this is saying 2 to the 256th power minus 1. So that's going to be the max value of a uint 256. Now we can use vm.assume. What this will do is it'll ensure that the input value from our fuzz testing is at least less than the maximum int. So what we want to do is we want to say max int minus 1, right? So that gives us that little bit of headroom so that we can increase it by 1. And we're going to say that y has to be less than that. We'll give this a save. We'll run our tests one more time. Great, it passes. But this shows the power of fuzz testing, right? We need to make sure then that our increment, right? Maybe we want to, in here, ensure that the value can't be at the max for a uint 256 if we're going to be incrementing it. That's something we could improve in this contract. This is just a basic, super fast tour of setting up a contract and tests in Foundry. If we look in the out folder, we can see all of the compiled files as well. If we look at counter.sol, we'll see the JSON. So this is going to be that ABI. If you ever need your ABI for something, it's going to be in that out once you've compiled it. It's great to know where this is, especially if you're interfacing with a front end or some other contract that needs that ABI. So you've got your Foundry set up, you've got Forge set up, you've made some contracts, but you want to take it to that next level. How do we do that? Well, if you head to the Foundry Starter Kit, so Smart Contract Kit, Foundry Starter Kit, we have a starter kit for Foundry, which basically will take all of the Chainlink abilities and give you a place to get started with them. So what does this look like? I've gone ahead and followed the instructions here to get started. I've cloned this onto my local computer. But one thing to note, if you don't want to clone it onto your local computer, you can click this Gitpod button and you can open this in your browser in a VS Code emulator in your browser and run it on Gitpod. Gitpod's a great tool if you don't have the ability to run things locally. But I've gone ahead and I've already cloned this locally myself. Now I've got the README here because this is that entire folder. And we can just kind of follow along with the README and install Foundry. We've got Git installed. We've cloned this to our local directory. We've got it all set up. I'll go ahead and open a terminal here. And it says the first thing that we need to do is run make test or forge test after we run make. So make installs all of the dependencies. So we run make. You can see here, it's removing the Git modules. It's reinstalling everything, ensuring that we have the right versions of everything. Everything is afresh in this install. All right, so everything's installed. We can look at the make file and see like what other options we have, right? So make all runs clean, remove, install, update, and build. So what does clean do? It actually just runs forge clean behind the scenes. Remove removes these files. Install runs forge install for a few different contracts. And then it runs build, so that runs forge build. If we run make test, it's the same thing as running forge test. But let's run make test because it's a little bit shorter to type. So we run make test and we see, wow, look at all these tests, right? We have tests for price feeds and API and VRF consumer and keepers. Whew, that's a lot. Where are all of these? They're in the source directory under test. And here you can see all of our different test files. One thing to remember in Foundry is that test files have this .t in the name. That's how it knows that it's a test file. So you can see the link here between these two. We have an API consumer and an API consumer.t. Right? If we wanted to look at something like VRF, when we have tests for VRF and we look at the tests here, it's really interesting. We pull in these mocks. Now, what are mocks? Mocks allow you to run a mock version of VRF. So when you're testing locally, you don't have all of the Chainlink Oracle network available to you. That's where the mocks come in. So this way we can mock, we can pretend to have an Oracle that we can get a response from. So what do those look like? If we look in here under tests and mocks and mock VRF coordinator, you can see it's setting up a few things and it's importing the VRF coordinator mock from our contracts that we're importing from the Chainlink contracts. That's really cool. What this does is it gives you the ability to act like you have a VRF call that's happening on a real blockchain. The same thing goes for price feeds, for keepers, and for the API consumers. We can see here all of the different mocks and how they work. There's also some utilities here. Cheats sounds bad, right? What cheats do is they allow you to manipulate your local blockchain. So if you want to do things like change the block timestamp, that's going to be this warp functionality. If you want to give different values, different contracts, stuff like that, that's another thing that's built into Foundry's testing suite. So we head back to the documentation here. Things to look at, right? We've got our first steps here. We didn't really follow this, but we kind of did. We ran the build and we ran the test. We can look at the different ways of creating projects. When it comes to writing tests, it'll walk you through everything you need to write tests. I know we kind of brushed past it, talked about it slightly. Their documentation is fantastic. There'll also be the Discord if you run into problems. When it comes to cheat codes, these are those ways of manipulating your local version of the blockchain. Explains all the different cheat codes. The Foundry documentation is really thorough and really great. I really appreciate the work they've done putting this out there. And personally, I love Foundry when it comes to just writing smart contracts that are pure smart contracts, and all I want to do is put my brain in Solidity mode and just code. So yeah, other than that, if you take a look at the Foundry TOML, you'll notice there's some other options here. There's one other file that I think is really important, and it's this remappings.txt. Now, when we take a look here at something like this @chainlink line, you'll notice it says @chainlink equals lib chainlink brownie contracts, right? That's weird. What does that mean? Well, if we go and look here at one of our import statements, it's basically remapping this @chainlink to point to lib chainlink brownie contracts. Then we have contracts, source, v8, interfaces. You can see where this is going, right? So this is just basically remapping your normal import statement to point to this lib directory. But it's something that's really important because if you miss out on this or you're trying to import another library, you're going to have a problem unless you remember to add it here as well. So yeah, that's Foundry in a nutshell. It's a super fast introduction to it. If you have questions, feel free to reach out in the Discord. I love to hear your questions, love to see what you build with this. And yeah, good luck in the hackathon. I can't wait to see what you build.
All right, so that was the pre-recorded Richard. This is the current Richard. Yeah, I have a question for you all who watched this. Did you like the pre-recorded version? Was it weird to have it like pre-recorded, not doing it live? Thoughts on that? Something new I'm trying out. And also, any questions that y'all have, I'll hang out here for a bit and answer them. But yeah, thanks for watching. That's all you've got any of this morning or afternoon or evening, wherever you are. I appreciate it. And we'll be on the Discord to answer any other questions you have as you run into them. But let me know if you have any questions now, and I'll be hanging out for a bit. Yeah, I was trying to, with the pre-recorded, to keep it compressed so I didn't ramble as much and spend too much time looking around. Can you explain in detail the remappings text in case I want to add a new? Yeah, sure. So let's take a look at remappings real quick. Let me rejigger my screen real quick. All right, so we've got here, this is the starter kit, remappings.txt. Basically what you want to do is when you import something, so if we take a look at the make file here and we look at this install command, for example, right? It's going to run forge install. It's installing the smart contract kit contracts. It also installs like Soulmate. But this example is what we'll use, just to kind of walk through this, right? So we install these. Where does it install them? It installs them in lib Chainlink brownie contracts, right? So lib Chainlink brownie contracts is where this gets installed. The remappings is basically just remapping anytime we use @chainlink, point to that lib Chainlink brownie contract. So if you wanted to install something like the Open Zeppelin contracts, you would do the same type of thing, and you'd add in like @Open Zeppelin lib Open Zeppelin slash, right? Maybe I got too many spaces in here, but does that kind of make sense, how you would map those across? Hopefully it does. If it doesn't, let me know in the chat. What else we got? I guess I'll put myself on the screen. Explain, it's cool. Didn't figure out it was pre-recorded. Well, it's good. I'm glad you didn't know it was pre-recorded. Can you use smart contracts test in script.js like in Hardhat or Truffle? So this question, when it comes to Foundry, your tests have to be all Solidity. So Foundry is like 100% Solidity. Even if you look here in the starter kit, and let's take a look at one of the scripts for deploying a contract, right? So even the deployment script, you'll notice this is written in Solidity too. So it's pretty crazy. When it comes to Foundry, everything is Solidity. So all of the tests are written in Solidity. That is it's a plus and a minus when it comes to Foundry in my mind, because one, you get to just stay in Solidity land, and from a learning Solidity standpoint, it can greatly help that, and you don't have to context switch between two different languages. Downside is if you need to do anything outside of what a smart contract can do, like hit an API, for example, to check a value, you can't do that like you could in Hardhat, right? Because Hardhat's tests are based in JavaScript. So it's a plus and a minus. Whoops. How to put, yeah, this is a great question, how to get Foundry online. So if we take a look at their documentation, they have here a section for deploying and verifying. So this is the official Foundry way to do things. You'd be running forge create, and then you'd be passing in the different values for your RPC URL, stuff like that. You could also take a look at the smart contract kit starter and our deploy down here for Go Early, which don't use Go Early anymore, use Spolia. We should probably update this in our starter kit, but it will run this script. And then it also runs some of the deploy information. That script is just going to pass in information to help deploy. So if you look at under scripts, and we're looking at the contract, we'll just pick a different one here, VRF consumer. You can see it pulls in some different stuff. When it's actually running, it has some things like the link address, subscription ID, stuff like that you'll pass in as well for that deployment, just to make things easier. Can we fork mainnet? I'm pretty sure you can. I don't know how to do it off the top of my head, but I'm guessing in here that they will have a section on that. So yes, it looks like you probably could from here. Where can I find more info about maxint that was used in the fuzz testing? Where did maxint come from? Sure, so when I was testing here, this test, so if we take this out real quick, run forge test. Let me make this bigger. I realized my video, my screen wasn't super big. We get this error message, right? And it says that we have this overflow, and it shows you the argument that was being used to test. So this is if you were to do 256, so what this line here for maxint is saying is, so uint 256 is going to be an integer with 256 bytes, right? And so 2 represents that 1 byte, times is going to be an exponent, so it's saying 2 to the 256th power. So this value here, whoops, this value here will be the maximum value of a uint 256, and then we'll subtract 1 from it because it's technically going to be 1 more than the maximum value with doing this like this. I hope that answers your question. Pardon the dogs barking in the background. Does it have a testnet? So your question, I'm assuming you mean can you actually deploy this to testnets? Yes, you can. You can deploy it to testnets for sure. Does Foundry still have problems with an M1 Mac processor? I don't think so, because this is a M1 Mac, so everything works just fine for me. I know it used to though, that's a good question to ask, because when the M1 Macs first came out, it definitely had problems. So yeah, any other questions for y'all? Thanks for showing up. And thanks for asking questions too. It makes it more interesting when there's some interaction. A forge test would run locally. So it spins up like its own instance of a blockchain and runs that locally. Answering this question. It runs locally. And to that point, like you'd want it to run locally, because if we had to wait for this to run on Sepolia, for example, man, this would take forever just to run like these 3 tests, right? Because we'd have to deploy our contract, wait for confirmation. And then we'd have to run our first test, wait for confirmation. Run our second test, wait for confirmation. And then the second and third test, these 2 fuzz tests, they actually run 256 times. So you have to wait for 256 block confirmations to go by. That'd be pretty crazy. And to that point too about the test nets, that's why in the starter kit, having those mocks to let you actually mock the different things that would be deployed on a test network are important, right? Because, for example, the VRF, like getting back the response from VRF, you need to make sure that that works without having actually deployed and running it locally. You need some way to emulate that. Are there any big projects developed using Foundry? I don't know of any off the top of my head, but I would be willing to bet that there definitely are. It's definitely a framework that is growing in popularity. When it comes to using it, I mean, the cost of like switching from Foundry to Hardhat, for example, if you decided to start with Foundry and then you wanted to end up using Hardhat, you'd have to change a few things probably about the layout of your project. All the stuff that you do, right? Like creating these contracts, for example. Well, not this one, that's a test. But like the actual contracts, all of these would just transfer right over. So you just copy these directly into another development framework, no problem. That's also the nice thing about like the import remapping, because this is how Hardhat would import things, and having that remapping, so it's just like I could copy this and put it into Remix, right? Which Remix is like an online IDE, and deploy this contract in Remix, and it would work. So that's one of the nice things. It's not like we're going from like a front-end framework, like we're changing from React to Svelte or something like that, where there's going to be a lot of work that has to change. So it would be pretty easy to switch between the two. But hopefully that answers your question. This is one of those questions too. Like, should I switch from Hardhat to Foundry? If you're using Hardhat and it's working fine, stick with Hardhat. Like, there's nothing wrong with Hardhat at all. It's kind of like saying, you know, I have one brand of drill that I'm using, and there's this other brand of drill. Should I switch? You can if you want. Like, if what you're using is working, stick with it. Like, Hardhat is definitely super popular, very widely used as well. Foundry is probably, honestly, less used widely, but it's growing, right? It's newer than Hardhat is. And again, it depends on how you're testing and what you're testing for which one you'd really want to use there, right? So if you're just living all in smart contract world, maybe Foundry is the way to go. I like it when I'm setting up smaller projects. For larger projects, Hardhat's great too. So it really is up to you. There's not a bad choice between the two. So yeah, no, it doesn't really answer your question fully of like, should I switch? Like, it's up to you. These are all great questions though. Well, cool. I will, I think, sign off then, unless there's any other questions show up in just a minute. If you do have questions, there is the Discord. You can reach me on Twitter as well. I'm at r.gottlieb. Let's pop it here in the chat. if you want to reach me on Twitter. My DMs are open, so feel free to reach out if you have questions and stuff like that. But yeah, can't use Discord chats, how to interact, look for a partner. Ooh, that is a good question. Go ahead and, if you can use Twitter, reach out to me there. If not, reach out, I'm sure there's a link other than Twitter or Discord. Let me see real quick what's on the Hackathon website. Yeah, if you can reach out to us on any of the other socials that are on like the Hackathon website down at the very bottom, we can definitely work on giving you help with that too and getting connected. I know most people are using Discord though for kind of getting partners and stuff like that. So, but we'll see what we can do. Alrighty, well with that, good luck in the hackathon, and yeah, I can't wait to see what you build. Like, I'm excited. So yeah, talk to y'all later.